Hi students, in this session we will learn important derivations from the chapter electricity. Question number 1. Resistors given as R1, R2 and R3 are connected in series to a battery V. Draw the circuit diagram showing the arrangement. Derive an expression for the equivalent resistance of the combination. Please watch video part 5 of the chapter electricity. Series and parallel combination of resistors has been explained in detail in that video. Here in this question, we have three resistors R1, R2 and R3 and they are all connected in series to a battery V. Then how will you draw the circuit diagram for this? The circuit diagram is like this. R1, R2 and R3 are connected in series. This is the battery V and the current I is flowing from the battery and the same current flows through all of these resistances. The potential drop across the resistor R1 is V1 and the potential drop across the resistor R2 is V2 and the potential drop across the resistor R3 is V3. The potential V is the sum of these potential drops V1, V2 and V3. Same current I flows through different resistances when they are joined in series. Let R be the combined resistance. According to Ohm's law, we know V is equal to IR. And what is V1? V1 is equal to IR1. What is V2? IR2. V3? IR3. I is the same because this is series connection. We have three resistors R1, R2 and R3 in our hand and we know the potential drop across these three resistors are V1, V2 and V3. V is the sum of V1, V2 and V3. V1 is equal to IR1, V2 is equal to IR2, V3 is equal to IR3 because V is equal to V1 plus V2 plus V3. Now we will substitute in the place of V, IR. V1 is IR1, V2 is IR2, V3 is IR3. Since I is common, you will take I outside. Therefore, I into R1 plus R2 plus R3. If I is common on both sides of the equation, you can cancel that. Therefore, you can write R is equal to R1 plus R2 plus R3. This is the equivalent resistance when they are connected in series. R is equal to R1 plus R2 plus R3. Second question, establish a relationship to determine the equivalent resistance R of a combination of three resistors having resistors R1, R2 and R3 connected in parallel. In the previous question, R1, R2 and R3 were connected in series. Now in this question, these three resistors R1 and R2 and R3 are connected in parallel. We have to find out the equivalent resistance when these resistors are connected in parallel. How will you draw the circuit diagram when they are connected in parallel? The circuit diagram looks like this. The resistors R1, R2 and R3, they are connected in parallel. These two are the two nodes. The current I, when it reaches at this node, it splits into I1, I2 and I3. Here in parallel connection, the current through each of these resistors will be different, whereas the potential across these resistors will remain the same as V. Three resistors R1, R2 and R3 are connected in parallel to one another between the same two points. These are the points. In this case, the potential difference across the ends of all these resistances will be the same. That is V. V is equal to V1 is equal to V2 is equal to V3. The potential is the same across all these resistors. If the total current flowing through the circuit is I, then the current passing through R1 will be I1. Then R2 will be I2. And the current passing through R3 will be I3. Then I is equal to I1 plus I2 plus I3. This current I is equal to I1 plus I2 plus I3. Here you must note that the current is different whereas the potential is the same. What is I1? I1 is equal to V by R1. I2 is equal to V by R2. I3 is equal to V by R3. Please note that this potential is the same everywhere whereas the current is different. From Ohm's law, I is equal to V by R. Therefore, in the place of I, you can write V by R. V by R is equal to V by R1 plus, we are substituting these values. V by R1 plus V by R2 plus V by R3. V is common, therefore take that V outside. Then you will be able to write V by R is equal to V into 1 by R1 plus 1 by R2 plus 1 by R3. Since V is the same, on both sides cancel it. 1 by R becomes 1 by R1 plus 1 by R2 plus 1 by R3. This is the equivalent resistance for resistors connected in parallel. 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. In this session, we learned the two important derivations from the chapter Current Electricity. For series combination, the equivalent value of resistance R1, R2 and R3 will be R1 plus R2 plus R3. And for parallel combination of resistors R1, R2 and R3, the equivalent value will be 1 by R1 plus 1 by R2 plus 1 by R3. These derivations are very easy. Just remember the Ohm's law, V is equal to IR. And for series combination of resistors, the current I will be the same throughout the circuit. And for parallel combination, the current will be different through each of these resistors. When current is the same, voltage across these resistors will be different. Then you will write the expression V is equal to V1 plus V2 plus V3 in the case of series combination and proceed. For parallel combination, the current through each of these resistors will be different, I1, I2 and I3. Therefore, I is equal to V by R from Ohm's law. Since I is different, V is the same. We know V is the same and I is different for each of these resistors. Therefore, I is equal to I1 plus I2 plus I3. In the place of I1, you must write V by R1. I2 is V by R2. I3 is V by R3. V is the same. You will get the final expression as 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Please remember the current is the same for series combination, whereas the voltage is different. Here for parallel combination, the current is different through these resistors, whereas the voltage V is the same throughout for all of these resistances. Thanks for watching the video. If you like it, please share with your friends. If you have any questions, please contact via email pjscracker@gmail.com.